Hello everyone, myself Nisarg Nagpurkar and I am going to present before you my SC205 final project that is about making an analog clock using discrete mathematics. First, let us understand how the motion of the hands of the clock are controlled. Clocks we know are run by a single battery source of power source. In order to move the hands of the different hands of the clock differently, it is necessary to have some mechanism. And this is provided by structure called gears. You can see in the given figure, the green gear is called the pinion and the blue one is called the wheel. The structure at its periphery are known as the teeth. As one teeth of the green pinion advances, so does one tooth of the blue wheel. Here the green wheel consists of 20 teeth and the blue consists of 16. So when the green one advances by 20 teeth, it completes one revolution. And so the blue one also advances by 20 teeth and it completes 1 by 3 revolution. So angular velocity of the blue one is 1 by 3 the angular velocity of the green one. So we can determine the angular velocity of wheel and through the angular velocity of pinion using this formula. So that's how we can make hands of clock which complete their rotation in different time intervals. The concept of median or the continued fractions. For two rational numbers p by q and p bar by q bar, their median is represented as m, that is equals to p plus p bar by q plus q bar. Now let us understand about the Stern-Proper tree model. It is a special type of binary tree. It is rather a complete binary tree. That is, it has exactly two children. It is rooted at 1 by 1. The key field is a rational number and the key value for each node is the median of its parent and its successor or predecessor, depending upon whether it is a right child or a left child. See, for example, here this node, the key value is 1 by 3, which is the median value of its parent and its predecessor. If it is a right child, then its value is determined by taking median of its parent and its successor. That's all about the Stern-Brokoff tree. Now we'll discuss its application. Why have we discussed this Stern-Brokoff tree and the median concepts? The reason is that it has application in determining the most suitable set of gears that we can use for making a clock with a given time of units. We may come across the ratio which is not possible to be factorized and so we can't implement using a gear tree, or rather it is not possible even using a larger number of teeth. So we can approximate this ratio with another one so that it can be factorized and so that its ratio is error is minimum. For that we can apply this Stern proprietary concept. How can we apply this? Let us see. Tree traversal using Euclid's algorithm. First let us discuss the algorithm. The algorithm says that if m and n are two distinct integers, then their GCD can be given by doing the following algorithm. That is, if m minus n is greater than 0, then replace m by m minus n, else replace n by n minus m. If n equals to 0, then m is the GCD, else repeat step 1 using new values of m and n. We shall apply this algorithm and derive a method for traversing through the Stern-Brokoff tree and finding out the most appropriate optimum approximation for our ratio such that it can be factorized and we can implement using a gear train. That is, while traversing through the Stern-Brokoff tree, we seek approximation to find the closest possible number by taking sign changes in the error as guidance to change directions of moving to right child or the left child. We shall explain this method. For finding out the most appropriate approximation of a number in the tree, we traverse down at each node down the tree and change the direction, either left or right child, depending upon the sign changes in the corresponding error in time induced due to current approximation and the error corresponding to its parent. That is, we may start from any node, but ideally we should start from the root and traverse down in any direction arbitrarily, either left or right, and then we should change our direction by taking account the error corresponding to the current node and its parent. If both are having the same sign, that is, both are positive errors or both are negative, then we should continue the same direction of traversal. That is, here taking the case of 3 by 1. If the error corresponding to it same is of same sign as its parent, then we should continue with the right direction, or else we should change the direction to the left. So after long traversal, we observe that the error induced is very small. So we notice that we are approaching the number closer and closer as we move down. Obtaining results. If we want an approximation of a rational number as close as possible and that which can be factorized easily, we can use this method and obtain it. For example, if we want a good approximation of the ratio 720 by 5 to 5949. By the way, this number occurs when we want to make a hand which completes one rotation in 1 year from a hand which completes one rotation in every 12 hours. This ratio comes, that is, the angular velocity of the hand which completes one rotation in a year is equals to 720 by 5 to 5949 of the wheel which completes the rotation in every 12 hours. But the problem is that this ratio can't be implemented using a gear train as the denominator can't be factorized. Also, it is not practical to make a wheel and pinion and a wheel pair such that it has so many teeth. So we can perform this method and we get an approximation which can be factorized easily. The approximation is 196 by 143175, and that can be factorized as follows. See, so the error generated in this approximation is very small and merely depends upon our choice. Significance. How can we commercialize it? By achieving those results, we can make our time tracking devices more accurate and precise. Precision may be improved in the clocks up to seconds or milliseconds to hours, days, and so on. Remember, it is possible through the construction of gear train. We have discussed this example lastly. New units of time can be designed as per our convenience.